Hello everyone, welcome to NextGen Build.
Where we explore next-generation machines and factory processes.
Today, we take you inside a bulldozer manufacturing plant.
Bulldozers are built for extreme power and durability. These machines shape roads, cities, and landscapes. But how are these powerful machines actually made? Every bulldozer begins with raw industrial materials.
Precision engineering defines every manufacturing step.
Thousands of parts work together perfectly. Automation ensures accuracy and consistency.
Let's start the complete, step-by-step process.
From raw steel to finished bulldozer. High-grade steel arrives in massive quantities. Only industrial-grade steel is used. Each batch undergoes strict inspection.
Strength and thickness are carefully measured.
Approved materials move forward.
Defective material is rejected immediately. Every piece is digitally tracked. Materials move toward cutting sections. Automation improves factory efficiency. Preparation for shaping begins here.
Engineers monitor production digitally.
Precision is essential from the start. Cutting operations are ready. Accuracy starts before cutting.
Machines are calibrated precisely.
Steel cutting begins. Transformation starts here.
Plasma cutters slice steel effortlessly.
Laser cutters deliver extreme precision. Perfect cuts reduce structural stress. Robots handle heavy steel safely. Components move for shaping. Laser cutters deliver extreme precision. Perfect cuts reduce structural stress.
Robots handle heavy steel safely.
Hydraulic force shapes steel precisely.
steel gains its final form.
Parts cool under controlled conditions. Parts cool under controlled conditions. Accuracy is checked again.
Edges are refined for durability.
Measurements ensure perfect fit.
Waste is recycled efficiently. Components move to frame assembly.
Manufacturing continues non-stop. Human skill meets automation.
Frame construction begins.
Strength is built layer by layer. The bulldozer backbone forms.
Heat treatment increases durability.
Controlled cooling prevents cracks. Welds are tested internally.
Quality approval is mandatory.
Each frame gets a unique identity. Frame moves to next stage.
Now comes the heart of the machine. Engine manufacturing begins.
Molten metal forms engine blocks.
Cooling ensures strength.
Precision machining follows.
CNC machines refine engine blocks with extreme precision.
Perfect surfaces reduce friction and increase engine life. Crankshafts are machined and balanced carefully. Pistons are installed to convert combustion into motion. Camshafts synchronize valve timing accurately.
Fuel systems are installed for efficient combustion.
Cylinder heads seal the engine tightly.
Each engine is assembled step by step.
Engines undergo bench testing before installation.
Performance, vibration, and efficiency are monitored.
Only engines meeting standards are approved.
Approved engines move to final assembly.
The engine is mounted onto the frame. Engine mounts secure power firmly.
Radiators and cooling lines are connected.
Exhaust systems manage engine emissions.
Transmission components prepare to transfer power.
Hardened gears handle massive torque.
Torque converters ensure smooth power delivery.
Engine and transmission work as one unit.
Precise alignment prevents long-term damage. Rotational tests confirm smooth operation. Mechanical strength is now complete.
Next comes the hydraulic system.
Hydraulic pumps generate immense lifting force.
Valves control hydraulic oil flow precisely. Cylinders convert pressure into powerful motion. Hoses are routed carefully to avoid wear. Leak-free connections are essential. Systems are filled with hydraulic oil.
Hydraulic pressure tests begin.
Systems operate under extreme pressure safely.
Any leaks are fixed immediately.
Hydraulics pass quality inspection.
Now the undercarriage is assembled.
Rollers support bulldozer weight. Sprockets drive the steel tracks. Idlers maintain track alignment. Track links form a continuous chain. Tracks are installed onto the chassis. Proper tension prevents premature wear. Tracks rotate smoothly during testing. Blade manufacturing begins next. Ultra-thick steel forms the blade.
Blade structure is welded securely.
Reinforced edges handle heavy impact. Mounting points connect blade to hydraulics. The blade is mounted onto the bulldozer. Hydraulics control blade movement. Blade motion is tested carefully.
Operator cabin construction begins.
Glass panels provide clear visibility.
Shock-absorbing seats improve comfort.
Joysticks allow precise control. Displays show real-time machine data.
Electrical systems, power sensors, and controls.
The cabin is secured onto the frame. Climate systems improve operator comfort.
Electrical systems are tested thoroughly.
The Bulldozer is now fully assembled. The machine is cleaned before painting.
Anti-corrosion treatments protect steel.
Painting begins inside controlled booths. Multiple paint layers ensure durability.
Signature colors define the brand.
Paint cures under controlled temperature. Finish quality is inspected carefully.
Branding and labels are added.
Final testing begins.
Mobility and steering are tested.
Load tests verify power. Hydraulics perform under full load. Tracks handle extreme terrain.
Safety systems are verified.
Quality teams approve the machine.
The Bulldozer is prepared for shipping.
Machines are transported worldwide.
Ready to build the future. From raw steel to unstoppable power. This is NextGen Build. From raw steel to unstoppable power. This is modern manufacturing excellence. This is modern manufacturing excellence. This is NextGen Build.
Thanks for watching.
See you in the next video.